Using best practices and technology to encourage scientific reasoning. The present-day understandings about learning and the availability of technologies are making it easier for teachers to engage students in meaningful, productive, work-like-a-scientist experiments. A range of devices and measuring tools, often called Probeware, are now available at reasonable costs for teachers. And depending on the devices used, you can connect multiple devices so that you can study more than one parameter at a time, gather data in the classroom or lab, or gather data from outside areas as well. And you can display data on large classroom devices so that students can make predictions and suggest areas to change, even if only one device is available. Many instructional resources and materials can aid your work. However, as you view the data acquisition going on in the background, keep inquiry in mind when you design experimental settings. Consider the different facets that you can ultimately address in a science lab. Don't just use cookbook or confirmation approaches. Use the full potential by engaging students in a conversation about the study underway. For example, while data is being gathered during this heating-cooling experiment, you could ask the students to work in their groups or individually to hypothesize about the outcome of this run, or challenge the students to recommend a variation on the experiment for the next curve to be captured on the same graph. Many conversations about the underlying molecular or conceptual principles, the reporting of scientific data, and the larger world value of this investigation can be spurred from meaningful data gathered by the students or the class. Often you can take classic cookbook labs and translate them into more inquiry-based approaches, using the prompting questions that come from the NSTA policy statement, or inquiry-focused authors such as Llewellyn. Teachers, educators, and parents must be willing to step out of the comfort zone of predictable labs. These new results can often be not as easy to explain. But the challenge of learning and explaining can be much more educationally productive than simply repeating rote procedures. Although a Nobel Prize may not be generated during one of your labs, you may be starting the curiosity and scientific reasoning that could lead there someday. Or at least you'll be creating good, logical, scientific thinkers. Challenge yourself and your students. You might be amazed at what you'll see.